No. Did you guys have any questions from your assignment?
Yeah, 19 through 26 for my question.
Did you guys have any questions from your assignment?
No, I didn't understand. It was nothing else I needed.
Well, I'll do it fourth period. Do you guys have any questions from your assignment? Maddie, any questions? You got it? Kate, any questions? Nope. Jimmy, questions? Nope. Joe? No? Austin? No? Gabby? All good? Kat? Eli? Not a one? Ty? Okay, you guys pass those forward. All right, I know you guys have a question on number 12. Okay? I know you guys have a question on number 12. This one is a rough one. Let's go through this together. So, right, did it with you and Sage yesterday, so you guys know what's up. Okay, number 12, 9x cubed plus 6x squared minus 3x. What can I factor out of those three? 3 and what else? An x, good. Okay, so that's going to leave me a 3x squared plus 2x minus 1. All right, so that part's pretty straightforward. Morning, Carter. Yeah, I heard you're videotaping or something. Yeah, okay. That part's pretty straightforward, so that's okay. But then we need to take and factor this stuff in parentheses into two separate smaller parentheses. And what makes that a problem is this 3 right here means that we can't just say two numbers that multiply to be -1 and add to be 2. We have to do that little trick where we go 3 times -1 is -3. And so now what I'm really looking for is two numbers that multiply together to be -3 and add to be 2. What are those two numbers? What? 3 and -1. Okay, so then I'm going to rewrite the stuff in parentheses as 3x minus x minus 1, because here's the 3 and here's the -1, all right? And then I'm going to take this and look at it as two separate individual problems. We've done this before, but it's a little complicated procedure, so I wanted to go through it with you guys again. What can I factor out of these two terms, the 3x squared plus 3x? A 3x. If I factor 3x out of 3x squared, what's left? X, good. If I factor 3x out of 3x, what's left? 1, okay. What can I factor out of -x minus 1? -1. And if I do that, what am I left with? X plus 1. And let me tell you, it is no accident that these two things are the same, okay? So what I'm going to do next to finish this is I'm basically going to factor an x plus 1 out of both of these. So if I factor an x plus 1 out of here, what am I left with? 3x. And then if I factor an x plus 1 out of here, what am I left with? Minus 1. And so this is the factored form of this. Okay? Okay, then the 19 through, what did you say, Emma? 19 through 26? Yeah. Okay. Like 24? You can even, okay, 21. Write a polynomial function in standard form with the given zeros. So if you know that, yeah. Yep. Yep. And then the last one is, good. Okay, so this is where we're working backwards. So instead of starting with the factored form and then you're writing the zeros, you're starting with the zeros and then you're writing the factored form, okay? So it's actually really easy. It's actually super easy to do these ones here. All right? Yeah. Yeah. You're absolutely right. So, well, x plus 5 times x plus 5 is just x plus 5. All right, now I'll take those. Okay, I lied. I'm not taking your assignments yet. I'm going to do 24. All right, 24, same thing. I've got 3 zeros, so I'm going to have 3 parentheses. Yeah, so x minus 0, which I don't really have to write the 0 because x minus 0 is just x, and then x minus 4, and then x plus 1/2 or 0.5. We'd rather just write the x though and do it like that. And that's it, yeah. Nope, not true. So one of the things that we finished with yesterday was we were connecting the zeros with the graph, okay? So this one had zeros at -2, 2, and 3, right? And so what that means is that the graph goes through -2, 2, and 3. That's one of the things that you get from knowing the zeros. Okay? What's that? And I'm not saying anything. Well, you're looking at me. Because I was wondering what was happening over there. Okay. Okay. Anyway, so the question that I left you with yesterday is what happens if you have two zeros that are the same? So in this case, we would be crossing the x-axis at -2 twice somehow, and then also at 2 and at 3. Okay? So to figure this out, let's go to the bat cave. Let's use a little technology. What would this look like written out as a polynomial so we can graph it? Okay, x plus 2 squared. So let's make sure we are all aware of what Kat's doing right there, because that's a really good trick and it's important. She's recognizing that since -2 comes up twice, then it's just going to be squared, right? And then what's the rest of it? Okay, so that is the polynomial that we would need to graph to see how this goes. So let's do that. Let's go x, let's go x, was it -2 plus 2? Thanks. X plus 2 squared. And then the next one was x minus 2, and then the next one was x minus 3. Okay, thank you. All right, so here's what the graph looks like. This is important. This is how the graph crosses, air quotes, the x-axis 2 times, okay? It doesn't actually cross it 2 times because it can't. What it does is it comes down and it just touches the x-axis, and then it turns around and goes back the same direction. And the reason why this matches with the squared is because if I look at just this little piece right here, what does it look like? A parabola, and parabolas come from x squared, okay? So when you square one of the zeros, then that means this becomes sort of like the vertex of a little mini parabola. And then over here at x equals 2, it just crosses the 1, and same with x equals 3, okay? So when you have a 0 that comes up more than once, those are, this is going to be a little confusing, but those are called, that's sarcasm on my part, those are called multiple zeros because they come up more than once, okay? Yeah, so, no. So if it comes up 2 times, it behaves a little bit like a parabola. If I change this into a 3, we haven't talked about that very much in this class, what cubic functions look like. But then that starts looking like a cubic, an x cubed, and so now it goes through again, okay? And so what's important for you to understand is that if the multiplicity, as we call it, is even, if the, it is, yeah, good hangman word, if the multiplicity is even, so for example, if that's a 2, or if I change that just for funnies to a 4, or I can change it to a 6. The graph is just going to come down and touch the x-axis 1 time and then go back the other way. If the multiplicity is odd, then it's going to go through at the x-axis, but it's going to sort of flatten out the bigger the thing is. Because of what Jimmy and I were talking about, because this piece right here, see how that to the 5th power? That piece right there looks a lot like what the graph of x to the 5th looks like. See how this and this have real similar shapes? Okay, and so that piece right there behaves in the same way as a graph like that would. Okay? All right, so if A is a 0 of multiplicity, yeah, then it's going to behave like a thing like that. Okay? All right, so let's take this from the beginning. Let's do a factoring problem, and let's not only find the factored form, let's find the zeros of the function, and then let's also use the factored form to figure out the multiplicities of that. Okay? Okay, so if I start with x to the 4th minus 2x cubed minus 8x squared, what can I factor out this time? X squared. Good. Not just an x. I can factor out an x squared. Okay? Because every term in there
I was about to Emma. When did
has, is it her phone?
No, she needs it.
Okay. Every term in here has at least an x squared in it. Okay? So if you factor an x squared out of x to the 4th, now what are you left with? X squared again, good, because 4 minus 2 is 2. What are you left with if you factor an x squared out of 2x cubed? 2x. And what are you left with if you factor an x squared out of negative 8x squared? Negative 8. Okay. What grade are you in, Kat? Not what? Gabby, what grade are you in? 11. Okay. Jimmy? Okay. You just multiply the top numbers together and you multiply the bottom numbers together. Super easy. You just do like 2 little multiplication problems. Okay, now I have to factor what's left. And so to do that, I need 2 numbers that multiply together to be negative 8 and add to be negative 2. What are those? Negative 4 and positive 2. Okay, so what are the 3 zeros of this function? What makes this 0? Positive 4. What makes this 0? Negative 2. And then here's the exciting one. What makes this one 0? 0. Okay, but because it is an x squared, that means that answer is going to come up twice. So this one is a multiple 0. It has a multiplicity of 2. And so what that means is if I graph the original function, the graph is going to go through the x-axis at x equals 4 and x equals negative 2. And at x equals 0, it's just going to touch the x-axis and then go back the same way. So let's check that to make sure, or so that you can see it. So x to the 4th minus 2x cubed. And what was the last one? 8 minus 8x squared. Okay, so there is the graph of that. So it goes through the x-axis at negative 2. It goes through the x-axis at 4. But at 0, it just touches it and goes back because 0 is a multiple 0. Okay, multiplicity 2. Make sense? What's the matter? No, she disappeared. She's not gonna just wait. I'm gonna pay for that for a long time. All right, so let's try another one. What can I factor out of there? An x. And that leaves me with x squared minus 4x plus 4. Now I'm going to factor the stuff right here. So I need two numbers that multiply together to be positive 4 and add to be negative 4. Those would be negative 2 and negative 2. And so since that comes up twice, that means that 0 has a multiplicity of 2 because it came up twice. So my two answers for this are x equals positive 2, which has a multiplicity of 2, and good, x equals 0. This one confuses you guys sometimes, but if it's just an x all by itself, then it's just x equals 0, okay? So if we were to graph this, then it would go through the x-axis at 0, and it would touch the x-axis at 2, okay? Okay, the last thing we're going to talk about in terms of graphs is what's called a relative maximum and a relative minimum. So there's a maximum, that means like the highest of all of them, right? And a minimum is the lowest of all of them. But there's also things that are like the highest thing around. So my example is, that I always use is that I'm a relative maximum because I'm the tallest guy in this class, maybe even in this school. I don't know, Canada's pretty close. But I'm not an absolute maximum. I'm not like a maximum because I'm not the tallest guy in the world, okay? So the same thing is true with these points right here. This is called a relative maximum because it's the highest point around, but it's not the absolute maximum because this graph goes forever this way, so there's points over there that would be higher, okay? Same thing with the relative minimum. This is at the bottom of a valley, so it's the lowest point around, but it's not the lowest point on the graph because that one goes down forever. It's really easy to use a graphing calculator. Desmos shows those for you. So if I graph this, x cubed plus 3x squared minus 24x, x cubed. Right, but this is free on your phone. Do you not have a phone? No. Well, I don't know what to tell you. You can borrow mine. Okay, Desmos is nicely set up to identify these things. So if you graph it, a little point will show up there and you can click on it. And it tells you exactly what that relative maximum would be and what that relative minimum would be. Okay, just so you guys know. That's where those come from. If you get to calculus, you'll spend some time figuring out how to find those mathematically, but we're not going to do that in this class. Okay? All right, so we are out of here at 9:10 because we have an assembly. I'm going to give you some problems to work on. And pretty high chance of quiz tomorrow, which would include the problems that were on the quiz on Monday. Did I give you guys a quiz on Monday? No, yesterday. The problems that were on the quiz yesterday, to make sure that you guys are understanding that before we go on, plus the stuff that we've done from this section. So, Jimmy, get ready for that.